Overview Video Guide for Container Equipment Inspection, produced by the Institute of International Container Lessors, IICL. Since the early 1970s, the Institute of International Container Lessors Limited, the IICL, has been setting technical standards and issuing manuals for the inspection and repair of lessor-owned marine containers. Chief among these standards is the Inspection Standard for Dry Van Containers, published in a manual titled Guide for Container Equipment Inspection. This guide is typically referred to by the letters IICL, followed by a dash and the edition number of the guide. The current guide is the 6th edition, IICL 6. This overview video is an introduction to the IICL 6 guide. By the end of the video, the viewer will have been exposed to the basic terms, concepts, and principles that underlie the inspection of dry van containers. In addition, the viewer will see several practical examples of how inspection measurements are made. This overview video will provide the viewer with enough information to use the IICL 6 hard copy manual and prepare the viewer for more detailed follow-on video modules which will reflect sections of the IICL 6 guide. The IICL 6 guide addresses the single most important set of inspection standards, those related to stress and impact damage on dry van containers. These standards are specified in Section 5 of the guide as dimensional deflection limits and are commonly referred to as inspection criteria. The IICL 6 guide deals with conditions such as dents that are directly related to the lessee's use of the container. These conditions are commonly called damage. They are conditions resulting from abusive or improper actions or otherwise using the container in a way for which it was not designed. Damage is reasonably avoidable by the user and typically the result of one or a few events. IICL 6 does not deal with wear and tear or simply wear conditions such as corrosion. Wear is a condition resulting from the normal deterioration of the container when it is used in the way for which it was designed. Wear cannot reasonably be avoided by the user, and it is usually the result of continuous deterioration over a long period of time and a large number of events. When repairs are not made to acceptable technical or quality standards, they're considered to be non-conforming repairs or improper repairs, or IRs. In a future video covering the IICL publication Repair Manual for Steel Freight Containers 5th edition, repair standards will be covered. Improper repairs are noted here to emphasize that a complete container inspection must not only identify unacceptable damage and wear conditions, but must also check for substandard repairs that have been made to the container in the past. IICL 6 primarily covers measurable damage, but there are types of damage such as the plywood floor delamination shown here that cannot be measured. These are commonly called gray areas. The IICL gives some guidance for inspecting gray areas in the Supplement on Container Inspection and Repair, Gray Areas, 2nd edition. But in practice, evolving commercial practices and owner policies generally guide the treatment of gray areas. Although the IICL 6 guide and this video primarily cover inspection criteria for measurable damage, a complete container inspection must check for all types of repair-worthy conditions: IICL measurable inspection criteria, wear and tear, non-conforming repairs, and gray areas to ensure that all defects that could pose an operational or safety risk are identified. Tables 5.1 through 5.9 in Section 5 of the guide list the inspection criteria. With the exception of a general rule that cut, cracked, or broken components and missing components are unacceptable, the majority of the criteria are listed as dimensional limits. The dimensional limits are used in one of two ways. The most common way is as the maximum distance from its original position that a component can be deformed, or bent, beyond which repair is required, called a deflection criterion. Using the standard container inspector's tools, a string line, and a 150 mm 6-inch measuring scale, the original surface is located with the string line and a measurement is taken from the string line to the deepest part of the dent. If the measurement exceeds the damage criterion, repair is required. Note that the measurement must be greater than the criterion to require repair. Alternatively, the criterion can specify the distance from some datum surface beyond which the component is not allowed to go, called an envelope criterion. The datum surfaces specified are usually the standard surfaces that the International Organization for Standardization, or ISO, uses to specify the envelope that a container must fit within. As these types of criteria are usually specified as a maximum amount the component may go beyond an ISO datum plane, they are commonly referred to as ISO plus or out of ISO criteria. In the example shown here, the inspector has used his string line and spacers to identify a plane 10 millimeters beyond the corner casting side faces. The corner casting side faces are the ISO plane for the container side, and the 10 millimeter dimension is the maximum amount that the IICL allows the corner post to bow outward beyond the ISO side plane. If any part of the corner post touches the string line, the repair is required. Note that the identical measurement method applies to the front and rear facing sides of the corner posts, except that the criterion is limited to 5 millimeters beyond the corner casting faces. Experienced viewers will note that the current edition of the IICL inspection criteria specifies fewer ISO plus criteria than did earlier editions. Experience has shown that locating the ISO plus surfaces under field conditions was sometimes difficult, resulting in inaccurate results. To alleviate this problem, the IICL used standard new production container dimensions to calculate the distances from the ISO plus datum planes to component surfaces accessible with a string line, and the calculated dimension was used to respecify the criterion as an easier-to-measure deflection criterion. These converted criteria are known as reference dimensions. The side panel outward damage measurement example shown later in this video is an example of the application of a reference dimension. Inspectors treat reference dimensions no differently than deflection criteria. Reference dimensions are described here to explain why certain ISO plus criteria have disappeared from the IICL standards. The only ISO plus criteria remaining are those for which a reference dimension could not be calculated. The terms standing corrugation and recessed corrugation are used in the IICL 6 guide. A standing corrugation is the flat corrugation face that is towards the viewer, while the recessed corrugation is the flat corrugation face that is away from the viewer. The definitions apply from the viewer's position such that a standing corrugation when viewed from the outside is a recessed corrugation when viewed from the inside, and a standing corrugation on the inside is a recessed corrugation when viewed from the outside. The maximum side panel outward deflection allowed by the IICL is 20 millimeters beyond the plane of the corner casting side faces. As it is difficult to locate a virtual plane 20 millimeters beyond the corner castings and directly over the point of maximum deformation, the IICL uses the reference dimension measurement approach discussed earlier. For standard dry van container designs, a 30 millimeter outward deflection of an inside recessed corrugation is equal to an outside standing corrugation deflection of 20 millimeters beyond the corner castings. The 30 millimeter reference dimension measurement is specified because it is easy to measure an outward deflection from the inside of the container. Note that the ISO plus 20 millimeter criterion is not mentioned in the table. It has been eliminated and replaced with the 30 millimeter reference dimension. In effect, the reference dimension has become the inspection criterion. The inspector locates the point of maximum outward deflection on an inside recessed corrugation. The string line will be placed in this recessed corrugation over the point of maximum deflection. The inspector places the string line magnet just below the top side rail in the recessed corrugation. The string line is pulled down over the entire vertical length of the panel. The entire length of the panel is included in the measurement, as both the dent and any underlying bow of the panel must be included in the measurement. The other end of the string is placed in the recessed corrugation just above the bottom side rail. The measurement is made from the string line to the panel at the point of maximum outward deflection. If this measurement exceeds 30 millimeters, repair is required. The identical procedure applies to the front panel, with the exception that the reference dimension is 15 millimeters. The cargo space inside a container, commonly called the cube, is defined by the planes of the floor surface, the standing corrugation faces for the sides, front, and door, and the plane formed by the top surfaces of the top side rails. Certain criteria limit the amount that damage can protrude into the cargo space or cube of the container. These criteria are commonly called into cube criteria, but like many out of ISO criteria, the IICL has respecified them as reference dimensions that can be easily measured with a string line and scale. In this container, we show how downward roof damage is measured to apply the 40 mm downward roof damage criterion listed in Table 5.5 to a container with tube-type top side rails. The most common dry van top side rail is a 60 mm square tube, so a string line placed at the bottom of the top side rails across the width of the container will be located 60 mm below the top surfaces of the top side rails. As the IICL damage limit is 40 mm downward from the top surfaces of the top side rails, any part of the roof that is less than 20 mm from the string line has exceeded the damage criterion. The inspector measures from the string line to the lowest point of the roof damage. If this dimension is less than 20 mm, repair is required. Many of the container's understructure components are C-shaped channels, and the IICL specifies inspection criteria based on what part of the C is damaged, the web or the flanges. The web is the vertical part of the component extending from the center of the bottom bend radius to the center of the upper bend radius. The upper horizontal part is the upper flange, and the lower horizontal part is the lower flange. When the crossmember is bent from the web side, the string line is placed at the outer radii of the lower flange at the undamaged ends, and the measurement is made to the outer radius at the point of maximum deformation. This method ensures that only the web deformation is measured and not the flange deformation, as the IICL 50 mm criterion only applies to the web. When the crossmember is bent from the flange side, the string line is placed at the inner radii of the lower flange at the undamaged ends, and the measurement is made to the inner radius at the point of maximum deformation. This ensures that the IICL 50 mm bend criterion is only applied to web damage and not the combination of web damage and flange deflection. In addition to the 50 mm maximum allowable flange damage criterion, the IICL does not allow any part of the crossmember, including the lower flange, to go downward more than 15 mm from its original position. The string line is placed on the upper surface of the lower flange at the flange outer edge. The measurement is made downward to the upper surface of the lower flange at the point of greatest downward deflection. For most container designs, the 15 mm criterion prevents the flange from going below the lower faces of the bottom corner castings, but to allow for unusual designs, the IICL also includes the additional criterion that no part of the crossmember can go below the plane of the lower faces of the corner castings. This video has covered the most important terms and concepts used in the IICL's Guide for Container Equipment Inspection, 6th edition, IICL-6, and has shown several examples of how the IICL inspection criteria are applied in the field. Future videos will delve deeper into the IICL-6 guide and eventually address the topic of container repair methods covered in the IICL's Repair Manual for Steel Freight Containers, 5th edition. And as you now have the foundation to fully and easily understand them, we recommend you read both. These manuals may be acquired directly from the Institute of International Container Lessors Limited. For more information, please contact the Institute of International Container Lessors, IICL. The general information email is info@iicl.org. For additional information online, please go to www.iicl.org/IICL6.